Hello, we're in lesson 6-6 talking about permutations and combinations, and we're looking at problem 3. So let's take a look at the key concept above. It says the permutation notation. So before we talked about factorial notation, and factorial notation is just when I have a number and an exclamation point at the end of it, and that means that I need to multiply by all the numbers going in descending order, subtracting 1 from each number. So for example, if I have 9 factorial, it'll be 9 times 8 times 7 times 6 and so on. So the expression NPR represents the permutation of n objects arranged R at a time. So if I have n objects and I have them arranged R in a group of R, then my formula for that would be n factorial divided by n minus R factorial. So for example, if I had 8 objects arranged in 2 different ways, that would be 8 factorial divided by 8 minus 2 factorial. And so I would evaluate this with the 8 factorial divided by 6 factorial, and I'll have 8 times 7 times 6 times 5 and so on and so forth, and then 6 times 5 times so on and so forth. However, I'm going to show you a little trick really quick. If I have 8 factorial divided by 6 factorial, I would do 8 times 7 times 6 factorial, and I would do times 6 factorial, and I would cross those out, and it would just leave me with 7 times 8. So that's a little trick that Ms. Case just showed you. Alright, so let's go on to the problem. It says, a band has 7 new songs and wants to put 5 of them on a demo. So here we have the thing that they were talking about up here. We have 7 objects, which are songs, so 7 new songs, and it's arranged in a group of R, which will be my 5. So how many arrangements of 5 songs are possible? So to find the number of possible arrangements, find the value of 7p5. And so the formula says that it's 7 factorial divided by 7 minus 5 factorial. So again, that's 7 factorial over 2 factorial after I evaluate in my parentheses. And again, using the trick that Ms. Kate just showed you. So we have 7 factorial over 2 factorial. That would give me 7 times 6 times 5 times 4 times 3 times 2 factorial, even though it's not as many this time to save me from the headache. It's a little bit, and so I would multiply all of that out, and I'm not going to do it because it actually gives it to me right here. It'll be 2520. Alright. Most calculators give you this option. Let me see, does mine do it? Let's see. Scientific. I don't see it here. Oh, I have the factorial button though, but not the permutation. Let me see if I go to my free graphing calculator at www.desmos.com. For those of us who don't have a calculator with us, we can use this free graphing calculator. And I'm going to go here to function, and I'm going to do stats because it's probably under stats, and here it is for permutation. So I have NPR, and so my N is 7 and my R is 5, and it gives me my value of 2520. Okay, so let's go back to the problem. And let's do the got it. It says there are 6 students in a classroom with 8 desks. How many possible seating arrangements are there? Okay, so we need to think about for a second, what is this asking us? Let's go back to the thing. It says, sorry, my mouse is not letting me scroll up. So it says that the expression NPR represents the number of permutations of n objects arranged R at a time. So we need the number of objects. How many objects do we have? So there's 6 students in the classroom and there are 8 desks, right? So how many objects are we arranging? We're arranging 6 students, right? So 6 students are going to be arranged in 8 desks. Okay, so a little hint. When I am doing a combination, excuse me, not combination, I'm looking down here. When I'm doing permutation, my largest number is always going to be my n. So let's think about this. Let me pull up my board. Let me do new. And so there are 8 desks, right? So there's 1 desk, 2 desks, 3 desks, 4 desks, 5, 6, 7, 8. And I got 6 little students over here. Right? And so these desks is in my classroom. These are the things that I'm looking at. I'm looking at these desks. So these are the objects that I'm arranging. And I have 6 students to fill these desks in so many different ways. So my objects that I'm filling are the desks. So my objects are my n would be the 8. And then I have 6 ways to fill them because I only have 6 students. I hope that made sense. And so let me do now again. And so I would have n equals 8, r equals 6. So I would use n pr equals, and I'm going to go ahead and change this to 8 and 6. So that would be 8 factorial over 8 minus 6 factorial, which gives me 8 factorial over 2 factorial, which gives me 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. Sorry, I ran out of space. And I'll multiply that out, and I'll do 8 times 7 times 6 times 5 times 4 times 3. Oops. Oh man. Alright, so 8 times 7 times 6 times 5 times 4 times 3, 2 factorial crossed out, so that's 20,160. We're going to use our free graphing calculator also to check our answer. Maybe Ms. Kate's made a mistake. So we have 8, 6, close my parentheses. So that's the same value that we got here. So 20,160. So there's 20,160 ways to fill those 8 desks for my 6 students. And I hope that this helps.